Basic probability. Basic definitions. Trials. Probability is concerned with the outcome of trials. Trials are also called experiments or observations. Multiple trials. Trials refers to an event whose outcome is unknown. For telling trials means out concerned with the outcome of trials. Trials also experiments, observations, multiple trials, and observations. Trials refers to an event, which event whose outcome is an unknown. Okay, sample space. Yes, set of all possible elementary outcomes of a trial. Set of all possible outcomes. All possible elementary outcomes. Trial. This is the of a trial. The trial. Okay, if the trial consists of flipping a coin twice, the sample space is S equal to head HH head dose head tail tail head tail. Okay, the probability of the sample space is always 1. This is a very important one. Okay, events. An event is the specification of the outcome of a trial. Specification, important point. For outcome of the trial in event. An event is the specification of the outcome of a trial. An event can consist of a single outcome or a set of outcomes. Complement of an event is everything in the sample space that is not that event, not E or E. Complement of event is everything in the sample space. Everything in the sample space. Everything in sample space. That is not event in the E or approximately. The probability of an event is always between 0 and 1. 0 and 1. Okay. 0 and 1. 0 from start from 1 maximum. So, the probability of an event and it is complement is always 1. The probability of an event, its complement is always 1. Several events. Then several events. The union of several simple events creates a compound event that occurs if one or more of the event occur. The union of several simple events creates a compound event. That occurs if one or more of the events occur. Several events. The intersection the intersection of two or more simple events. Two or more simple events creates compound event that occurs only if all the simple events occur. Okay. If 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 events cannot occur together, if events uh, if events cannot occur together, they are mutually exclusive. Here, 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 here. So mutually exclusive. ठीक है ना? Okay. Then the interest of one or more events creates sorry this point. Okay. The integration of two or more simple events creates compound event that occurs only if all the simple events occurs. The first part you have seen. The intersection of two or more simple events creates in a compound event that occurs only if they all simple events intersection. Okay, if events cannot occur together, they are mutually exclusive. Outside here mutually exclusive. If two trails are independent, if two trails are independent, the two events are independent, if two trials are independent, the outcome of trial the outcome of trial does not influence the outcome of another. The outcome of the outcome of trial does not uh, does not influence the outcome of another. No influence. Okay, both are different. Okay, permutations. Permutations. Okay, permutations. Permutations are all the possible way elements in a set can be arranged where the order is important. Permutation are all the possible ways. Possible ways elements in a say elements in set can be arranged where the order is important. The order is important. Okay, this is the important. The number of permutations, the the number of permutations of subsets of size k drawn from a set of size n is given by the number of uh, the number of permutations the number of permutations of subsets of size k size k drawn from a set of size n set of size n, this is k. Okay, is given by this is then you have to add p, this is n, then probability, then k. K only happened, no? So that's why k. So n factorial, this is come here. Then divide by n, we have to minus from n, this what happened, we have to minus. Then n pk. Then permutation, we got it. Okay. Okay. Continuation. Sorry, combinations. Combinations are similar to permutations with the difference that the order of elements is not significant. Similar like permutations with the difference that the order of element is not significant. Order of the element is not significant. The number of combinations of subsets of size k of size k from a set of size n, this is n, is given by, this is big one here. Then permutations, p for permutations, then k combination of subsets, this is combination of subsets. Okay, so this can come here, n factorial divided by k, this k factorial, we have to minus from total n to this k factorial. Then you have to multiply with k combinations. Probability of events. If two events are independent, this is for event, this is for event, this is E, this is F. Two independence. If two events are independent, then total what will happen? P equal to E. The probability of both E and F occurring is like this only. This one, no? Intersection equal to P of E P F. If two events are mutually exclusive, if two events are mutually exclusive, if two events mutually exclusive, the probability of E, this one E or F equal to, then this one E, this one F, then mutually exclusive. So to be add, that's all. If the events are not mutually exclusive,